All right, so here we go. Number one, we already kind of did this one before lunch. If you take the limit as n goes to infinity of your rule of sequence, you get n cubed over 4n cubed, so it's 1/4, and so diverges by the nth term test. So I'm just going to put D for diverges. Letter B. This one converges by the geometric series test. 2/7 is less than 1. Now we can actually figure out what this one converges to. What would be the first term if you plug in a 0? 1 over 1 minus 2/7. So that would be 7/5. This one converges to 7/5. Okay? This one converges by the P series. The 4 is not going to be a problem because you can really pull the 4 out front. So if you do that, you're left with 1 over n cubed. It's a P series that converges because P is 3, which is greater than 1. Letter D, n squared over 5 to the n. This one converges. Intuition should tell you that. What test would you use? The ratio test works fantastic on that one. Good. And you'll end up with n squared over something n squared. And it will go to something less than 1. Okay, this one here, what do you think? Converges. Yeah. This one you would compare it to, you could use a direct comparison test or a limit comparison test, and you would compare it to 1 over n to the 5/3, right? And then you would say that because you're adding plus 5, that one is smaller, and anything that converges, then anything smaller will as well. So it converges, P series. F, this one's kind of interesting. What do you think about this one? Converges? You're correct. If it were just 1 over n, it would diverge, right? It would be your divergent P series. So remember, all we really need for that to be convergent is to get just a teensy-weensy bit more help. Because if it had been 1 over n to the 1.00000000001, or even more zeros than that, now all of a sudden it would converge. So all you really need is just a little tiny oomph more in the denominator to help n get bigger slightly faster. Now the natural log is about as small of an oomph as you can get to help, right? Because it grows pretty slowly. Raising it to the 4th power kind of helps. But it does give it the necessary oomph to intuitively converge. Now what test would you use? The direct comparison is not going to be helpful because you're going to have to compare it to 1 over n, which is a divergent series. This one would be, how about this? What if we did 1 over x times the natural log of x to the negative 4th power? This would be the integral test if you had to figure it out. Because if you replace those n's with x's, then this is something that you could integrate, right? And just for what it's worth, the inside function would be the natural log of x. Its derivative is 1 over x. No correction necessary. So then blob to the negative 4th becomes blob to the negative 3rd times negative 1/3. And you will see that that from 2 to infinity ends up being a finite number. So to prove it, integral test, you'd also have to say that the terms are decreasing, continuous, and positive. Dogs cussing in prison. But on a multiple choice question, intuition goes a long way. Converges. All right, G. You have basically an n squared over an n cubed. Converges, yeah, the terms go to 0. So this has the possibility of convergence. The terms go to 0. But you would compare it to 1 over n, right? If you simplify n squared over n cubed, you compare it to 1 over n, which is a divergent harmonic series. So this one actually diverges by the limit comparison test to 1 over n. Okay? Just because the terms go to 0, remember, doesn't mean that the series does. Remember, the limit comparison test says you take one divided by the other, doesn't matter which one, and then state change flip, you would end up with 5n cubed over 1n cubed, which is 5 or a fifth. And as long as that number is positive, they have the same behavior. H. Converges or diverges? Converges by the alternating series test There is your covert alternator. Okay? Integer powers of pi simply alternate sign. 1, negative 1, 1, negative 1. Would this be conditionally or absolutely convergent? Conditionally convergent. This is conditionally convergent. Because without the alternator, 1 over n to the 1/2 would be a divergent p-series. So this is a conditionally convergent alternating series. I converge or diverge? Diverge by nth term test or ratio. Either one. J, converge or diverge? N to the 5th over n to the 5th. Leading coefficient over leading coefficient is negative 6/9. Is negative 6/9 0? Nope. So this one, or negative 6 negative 9 is what I meant to say. Yeah, it doesn't really matter. 2/3. It diverges by the nth term test. K, converge, diverge. Converge, good. By the limit comparison test to what? 1 over the square root of n to the 4th, which is 1 over n squared. That one's a little tricky. You have to take everything under the radical. It does simplify to 1 over n to the 4th, and the radical, which is the square root of n to the 4th, would be 1 over n squared. So because 1 over n squared is a convergent p-series, that's the same as 1 over the square root of n to the 4th. You would then take the limit underneath the radical, and you'd end up with 3 square root of it. And because the square root of 3 or the square root of a third, whichever one you did, is a positive number, it would converge. L, converge or diverge? The top grows faster because it's a power of 3 to the n instead of 2 to the n, but the bottom also has a little helper. I want to help, I want to help, I want to help, said n. Does that help 2 to the n defeat 3 to the n for large n? No, it doesn't. This one diverges. And what test would you use? You would have to use the ratio test. Yeah, because the n is there, you'd have to use the ratio test. If the n wasn't there, you can almost turn it into a divergent geometric series. This one here, converge or diverge? Converge. Kind of tricky, isn't it? If you do the nth term test for divergence, you have 2/5, right, as the limit on the inside. But it's not just 2/5, it's 2/5 to the nth power. So 2/5 times 2/5 times 2/5, that's getting really small really fast. So it does go to 0. And so this does actually converge by the what test? Root test, yeah. 2/5 is less than 1. This one. Converges by the root test again? Yeah, you can do the root test. Yeah, anytime you can write the entire thing as a power of n, and 1, of course, is a power of n. So the nth root of all that is just 1 over the natural log of n, which as n goes to infinity, the natural log of n goes to infinity, so 1 over infinity goes to 0, and 0 is less than 1. So it converges by the root test, yeah. Now, without that power of n right there, 1 over the natural log of n, just for what it's worth, what would you say about that? That one would diverge, yeah, big time. Okay, but what if I put negative 1 to the n up there? Now it converges conditionally. Yeah, cool. Element O, converge or diverge? The series. It diverges by the nth term test. You could also do the root test, kind of. If you take the nth root, you get 1 plus 1 over n, which actually goes to 1. and the nth term test is inconclusive, unfortunately. But it's a good candidate for the root test. This one actually diverges by the nth term test because what is the limit as n goes to infinity of 1 plus 1 over n to the nth power? E. You might want to memorize that. 1 plus 1 over n to the nth power goes to E. You don't want to have to use L'Hopital's rule. It's worth remembering. This approaches E. And E is not equal to 1. Or 0, sorry. So it diverges by the nth term test. What?
It's not equal to you.
What did I say?
You said it's not equal to 1. Well, it's not equal to 0. But it's not equal to 1. That's what it is.
Oh, true. True. Yeah, the nth term, I wasn't wrong, but it wasn't citing the test. Yeah, okay. How about this guy? I think we already talked about him. This one is conditionally convergent. By the alternating series test, it converges. Take away the alternator, and it does not converge on its own. Poor thing. All right, so there they are. Intuition, again, can take you far. There is a way to summarize all these if you want. If you think of Moses parting C gives you a way to remember there's a name for everything. P series, alternating series, ratio / root. Telescoping, that's kind of a neat one. Not on the AP exam. Integral test, dog discussing in prison, nth term test, geometric series, and comparison test, limit and direct. Now, parting C helps you remember the names, but you don't even really need to know the names. You just need to know how to do the test. And, of course, if you think about it as a sequence here, you would really want to start with which letter? Like if you had a flow chart. N. Nth term test you always consider first. It could be a big time saver. All right. Any questions on this set? It was a huge section. Got you introduced to series. Talked about sequences. Want to remember. Practice the worksheet. There's some multiple choice questions on there that are similar to ones on the test.
How much would you say of this is like actually on the like, a lot of the big stuff?
Straight up sequences and series, you might have like 2 multiple choice questions total.
But
maybe 3.
Could it be on like free response? Or?
It could be. If it's on a free response, it's probably going to be more in terms of what's coming up next. Yeah, which there could be like an alternating series remainder thing on there. I think we saw two like this. We worked through a first part of a practice test on Saturday, and I know for sure there was one on there. There might have been 2. It was asking about conditionally and absolutely convergent. All right, so practice 9.1. Come with questions. I don't think we're going to quiz. We'll just we'll roll out right into the next section. So go ahead and